Thanks, Simon. Just to introduce myself, I am new to UKNOF, so you probably won't have seen me around before. But I'm Alistair Wooldrige, and I lead the media distribution team, which is it's part of the BBC's online technology group. So one of the things that this team builds is the BBC's in-house content delivery network, and that's what we call BIDI, and what I would go through today. Just for a bit of background, before hopping over to product management, I was previously a senior software engineer on BIDI itself, and started the production code base quite a few years ago. So I have been on this for quite a while. So three main sections to this talk. I'll first give an introduction as to why we're actually building a media CDN in the first place. Then I'll take you through how BIDI's grown so far, so from nothing to where it is today. And then lastly, highlight some of the plans we've got for the future. I am trying to cram a lot into these 25 minutes, so apologies in advance for having to go through these at some speed. So getting straight to it. The BBC has quite a lot of media to distribute over the internet. The obvious heavy hitter in terms of traffic is iPlayer. That's got all the on-demand catch-up content, the box sets, and it's also got the simultaneous live feeds of the broadcast channel, so the BBC One, the BBC Two, etc. Then there are others that you don't always think about, perhaps, so things like BBC Sounds, that's got plenty of podcasts and live radio on that one. And then BBC News and Sport as well. They've got lots of video clips that tend to accompany the articles. And the clips themselves are actually quite small, but they have that additional bit of fun that they're often viewed as a result of a push notification to people's devices. And there's nothing quite like a push notification for getting everyone playing exactly the same video at exactly the same time all around the UK. So to give just a flavor of the type of clients that are using these services, this is just a rough traffic breakdown to our media CDNs. It is in terms of initial playback requests, but actually maps pretty closely to the bytes served too. And just to be clear, when I talk about the BBC's media CDNs, I'm talking about those used for the video and audio streaming, not for caching things like web pages or web page objects. So about 66% of our traffic is from TV clients. It wasn't always this way. That proportion's been kind of steadily growing from about 25% in 2015 up to the 66% that we usually see now. And of course, those TVs, they don't want the standard definition streams. They go for the biggest that they can get their hands on. So they do drive quite a lot of the traffic. So all the clients, they're streaming using a method called segmented media. So I thought best have a quick look at that in case it's not familiar. So what we've got here is an episode of EastEnders, which someone is streaming from iPlayer. Could be on their phone, a TV, pretty much a good old web browser. It's all pretty much the same. So when they hit play, their client doesn't just go off and download that entire video episode as a single file. It's being spoon-fed to them as a sequence of pretty tiny, roughly 4-second long video files. And all in all, for an episode like this, which is about 20 minutes, there's about 300 of them. So then during playback, that client is downloading just a handful of them in advance, and it's seamlessly stitching them together to create a gap-free playback. And there's nothing really special about this at all. It's how media's been streamed over the internet for quite a long time. The great thing is that they're just boring old files that are delivered over HTTP. So no need for any fancy server logic. Segments can be served by any old web server. And that pretty much means that they can be distributed by any old CDN as well. So widely compatible and fairly simple to distribute at scale. So layered on top of the segmented media delivery is adaptive bitrate switching. And this is a method to provide the same stream in multiple different bandwidth profiles. Perhaps unlike with the gigabit community broadband presentation we've just seen from David, not all clients are sitting in a fiber to the premises home watching on an Ethernet connected TV. And we've got some clients that are streaming on perhaps a creaking old phone, barely within reach of a 3G reception. And for these clients, they're probably not going to be able to have enough bandwidth or perhaps even processing power to download the full HD segments fast enough to keep up. So instead of them just sitting there on a spinning wheel, that client can jump lanes midstream and switch to a lower quality version of a segment as it needs to. It's pretty nice and easy to see this in action. You just need to open your browser's network tab whilst you're playing a video. So you can see here, those segments are being requested sequentially by the browser. You've got the 1.m4s, 2.m4s, and so on there. So iPlayer has hundreds of thousands of these streams all running concurrently at peak, which adds up to quite a large amount of combined throughput, which is why we use a combination of both third-party CDNs and BIDI to distribute this. Giving a rough overview of how they all fit together, all the CDNs are configured as pretty much run-of-the-mill pull-through caching. So they all act as reverse HTTP caching proxies. So the very first time you get a client requesting a segment, that CDN requests it from the origin, then it stores a local copy of it so it can provide the same one to subsequent clients. To decide which CDN the user should go with to start with, we've got a Cdn Selection Layer called Media Selector, and that's a custom BBC one, and it allows us quite fine-grained control over that CDN mix that gets returned to the user. And then once a client has been issued a CDN, if you like, it sticks with that one for the duration of playback unless there's an error, and then it can actually switch to a different one. So BIDI enters as just another provider in the CDN mix, and on the whole, we do try and keep BIDI as generic as possible and try and avoid putting in too much BBC-specific functionality where we can. Realize I've left this quite late, but something we should probably get out of the way to start with is what BIDI actually stands for. It's not mind-blowing. It stands for BBC Internet Distribution Infrastructure. I've been on the project since pretty much the start, and I still don't really know where that came from. Some think it's a Buck Rogers reference. There's a robot character on that called Twicky, which goes around saying BIDI, so that often gets bounded around as an origin. One thing for certain, though, it has absolutely nothing to do with bidirectional transceivers. I'm sure they're great, but we don't use them. We've never used them. It's just an unfortunate naming collision, that one. So why are we building our own CDN at all? The first reason is to ensure that the BBC's fit for an IP distribution future. And by that, I mean that consumption modes are on the move. They're going away from the terrestrial, the satellite and the cable, but also consumption shifting perhaps without people even knowing it. So you've got features such as play from the start on TVs, live rewind, you might have heard it as, and UHD. These things can only be distributed over IP. And the clients these days are making it quite a seamless experience to use them as well. Second reason is to ensure the audience is getting a good quality of service, because there's absolutely no point in all this viewing transitioning over to IP if the audience then ends up staring at a spinning wheel of death. So by us having fairly complete control over the hardware and the software components, we can optimize for our exact demands both now and in the future. BIDI only serves UK public service content at the moment. It's not used for any worldwide distribution at all. I mean, it doesn't serve all UK content either. It's not serving at the moment live video, live audio, or on-demand audio. And the reason for that is to keep BIDI's efficiency high. So it's really only targeting the very high volume on-demand video content sets, because they pretty much have predictable traffic patterns and very high volumes. And that accounts for about 75-ish% of the BBC traffic anyway, from the breakdown here. So now I've taken you through why we're building BIDI. I'll now show you how we're doing it. So BIDI started life as an idea in BBC R&D, and they asked what seemed like a pretty daunting question at the time, which was, could the BBC build its own CDN? And in particular, could it do it using commodity hardware and open source software? So they spent a couple of years doing what they do best, researching and developing, and out of that spun a prototype. This was put into production with a small amount of traffic, but that gave everyone just enough confidence that it actually could be done. And here was some running hardware and software that proved it. So I jumped on board about 2015. Our job then was to take this proof of concept and build it into a robust and a scaled production system. As is normal with handovers, I don't really think it matters if the code has been written by Dennis Ritchie himself. The first thing that any new team does when they get handed some code is to open up perhaps just one of the files, have a quick scroll up and down, and immediately decide the entire thing needs a rewrite. So that did keep us busy for quite a number of months. Next, let's have a look at what BIDI's made up of. This is the basic workhorse unit of BIDI, and we call it a battery. It's the smallest unit of deployment within a POP, and it's made up of a single layer 3 switch. That's used for two things. It's for high availability and port aggregation. And then there are 2 to 4 caching cells, and these are really just commodity servers that we pack with SSDs. And as I mentioned earlier, they just act as reverse HTTP caching proxies. So servers being servers, one thing we do know is that they do occasionally blow up, and the purpose of a battery is to provide high availability. So it does this by providing only one audience-facing virtual IP, and that IP is what the clients connect to when they actually want to grab content for playback. So to achieve this, each of the caching cells maintains a BGP session with the switch, and every cell advertises the same virtual IP. So in normal operation, the switch uses ECMP, and it balances the connections reasonably evenly across all the cells in the battery. If the server should blow up, that session's severed and the switch removes it from the pool. And each of the cells are stateless as well. They have the same copies of the content. There's no real problem with clients failing over between cells in a battery. We also run each of these batteries with an active-active kind of N+1 resilience model. So one server can always fail and the others are there to take the load of it. So we've got our BIDI battery. There are 2 options on where to stick it. The first option on the right-hand side here, that's for us to run them inside BBC data centers, and then these can be reached via public and private peering. And then the second option is to have the battery embedded inside an ISP POP, and we run it as a remotely managed service, and customers local to that POP will stream directly from that battery. So how does a battery know which clients it should serve? BIDI doesn't use IP geolocation or any of that type of voodoo. Instead, it relies on the ISP providing the ranges that should be served directly to the battery itself. And it does that through a BGP feed. So BIDI can support multiple modes too. The example here, you've got that feed from the directly connected router, but it doesn't need to be that way. It can be from a multi-hop central source if needed. But then that battery forwards the ranges into BIDI's centralized BIDI brain, and that aggregates all the ranges received by all the batteries across the estate. So now we've got a client, it wants to start playback, and BIDI needs to direct them to the most optimal battery. The service that does that is called the matchmaker. It really only has one job, is to determine the most optimal battery for the client and just send them on their way to it. So to do that, it first extracts the client's IP address, does a longest prefix match against all the IP ranges that it knows about from the batteries, and it'll use things like AS path length as tiebreakers for that one. Then the matchmaker just issues an HTTP redirect, and that client is sent on their merry way. From this point on, the client switches to the BIDI battery, and it stays with that one for all subsequent playback. It does only ever uses the matchmaker at the very start of playback. So that's what BIDI's made up of. Took us through to around 2018-ish to get that fully production ready. And then from 2018 onwards, we've been focusing on scaling BIDI up and out. So this is where I can show you pretty much what we all really care about, the stats and the graphs. So starting with the number of caching cells in BIDI's production environment, of which there are 102 at the moment. And as you can see, it didn't just happen overnight. This graph shows the number of servers in active production use since late 2015 until now. And we've been gradually adding more and more capacity over the last couple of years. And not just that, but throughout this time, about 50 servers have been decommissioned and refreshed. So it's been keeping our relatively small teams pretty busy. In terms of the overall BIDI estate size, these 102 servers are organized into batteries, and that's using about 26 switches in total. Then those batteries are deployed across 24 data centers. Some of those run by the BBC, some are within service provider networks, and we're currently in 3 of those. And this map is showing the actual spread of the POPs, so they are distributed around the UK. Although it's a relatively modest amount of servers, it does mean we're managing over 1,200 SSDs, which does keep us on our toes. So as I mentioned, we run BIDI batteries inside BBC data centers, and those are reachable via public and private peering. In terms of our public locations, for links, we're at LON 1 and LON 2, and also at IX Manchester. We're at LON App as well, and we do have presence at IX Scotland, but the actual content is served from the same caches as IX Manchester for now. In terms of private peering, for London, we can do this from Telehouse Docklands or Sovereign House, and in Manchester, we're at MA1. We're also looking to bring a new data center online, and that's at Equinix Slough in about 2021. So for the BBC data centers, again, we run them with an N+1 resilience model, so there's always enough capacity for an entire site to fail, and the others can take up the slack. Back to the stats, this is showing BIDI's monthly traffic peaks from 2015. I guess unsurprisingly, it maps quite closely to that number of servers graph that I showed earlier. So between 2015 and 18, traffic was quite low, but that was because we were building the foundations back then. But even then, it did increase from about 55 gig to 300. Growth has been most rapid since 2018. We're up to a peak of 1.2 terabits per second so far, and this isn't really hitting the limits of BIDI's capacity either. So I do expect this to continue to grow over winter, even if we were making no changes to the hardware at all. Looking a little more closely at that 1.2 terabit peak, there were 3 main programs popular at the time. We had Match of the Day 2, a new series of Top Gear just started on the evening before, and EastEnders. It's just not a normal day if I don't sit down with my morning coffee and see how many gigs that EastEnders has pushed on the evening before. It is always up there. Looking even closer at that peak, there were nearly 250,000 concurrent streams, and that's 700,000 TCP connections established to the BIDI servers at that time. Offload was fairly high at 96.7, and for all of this, the sum of the BIDI servers drew a combined 26 kilowatt, or as I like to think of it, about the same as running 9 domestic kitchen kettles. If calculating an average, that means for BIDI to stream an episode of EastEnders, which are normally about 27 minutes, 15 seconds long, not at the moment, it uses about 0.048 watt hours of energy to do so. This is just the server, sorry. It doesn't include the switches, doesn't include data center power consumption or any consumer equipment, but I did want to include it here as I've seen some pretty ridiculous stats going around, particularly how streaming one show can be as bad for the environment as going on a drive. So I thought I'd include this one here because you're not going to get very far on 0.048 watt hours of power. This is the offload achieved from the direct audience-facing servers, and it's over the entire month. BIDI doesn't have a mid-tier as such, but if you do remember back to one of the earlier diagrams, there is a BBC-hosted cache tier that kind of sits behind all the CDNs, so that does effectively act as a mid-tier, and we treat it as such. But this graph is just showing the offload achieved by the edge BIDI servers themselves. And as you can see, it really isn't always perfect. If we don't intervene, it will gradually trend downwards, and that's due to the growth rate of content that's available on iPlayer, and also things like increases in quality as well, so that balloons the size of the files. This is what that growth rate looks like from the CDN's view, and this shows the video on demand working set, and it effectively tells us how much cache storage is required should we want to fit a full 24 hours of content on disk. You can see here it took about 55 terabytes to fit a day's worth in 2018, but already just in 2 years' time, that has grown to nearly 130 terabytes, so over a 2 times increase on that. If you're going to follow this trend, we'd need to pretty much double the amount of SSD storage in a cache server at least every 2 years to cope, which is why we're looking at other ways to optimize this, which I'll go into a bit more detail later. Something we've paid a lot of attention to over the years is the actual hardware makeup of the caching cells themselves. We just use commodity servers here. There's nothing too special. They've got a CPU, some RAM, SSDs for caching, and a NIC. And when BIDI started, a 2U server was only able to push about 4 gig. And then over time, we've managed to get this up to 20 and then to 70. Actually, we're even a bit higher than that still. Looking at the detail, CPU has been getting a bit more beefy. We've always used dual cores, but actually the core count and the clock rates just been growing naturally over the years. The most important changes have been to the actual cache SSDs themselves. So early on, they were the main bottleneck for throughput. And as you can see, the storage has increased. So it's gone up from 1.3 terabytes at the start, and it's now over 80 terabytes, which is about a 50 times increase. And not only that, the connectivity and the configuration of those drives has changed too. So at the start, we used a hardware managed RAID 1+0 array, which was just terrible for performance. Now in the most recent generation, we've completely ditched any type of RAID, and we're connecting them with NVMe. Of course, with all this, we've had to increase the NIC performance in line with it. So we started with 20, and then moved up to 50, and now we're up to 100. I can't go through this without having a good old moan about our biggest pain point, which is SSDs. And having been on this project for quite a long time, my colleagues are used to me having a good old moan about SSDs. There's way too many problems that we have to list them all here, but just to pick a few. To start with, some controllers on the SSDs themselves perform transparent compression, and this can cause the drives to perform artificially well with certain types of content. And that's not always a bad thing if you know about it, but it's most off-putting when you've got a drive that excelled in load tests, but might as well have been a bit of spinning rust when you put it in production. We've also had some drives that perform great when they first entered service and in load tests, but after about 4 drive rates, it varies a bit, performance would just completely drop through the floor. And that was a fun Tuesday afternoon when we realized that about 100 production drives had become ticking time bombs. Some drives, they just burn out quicker than they're meant to. And some drives, they just disappear from the bus with no warning. And the only fix is to do a cold reboot. And one of our engineers in our team has gone into a lot more detail than I have in this blog post, which I've linked here. Thankfully, in recent years, we've become pretty good at load testing these things. And actually, the performance of the SSDs themselves have come on such a long way that many of these problems have just gone away naturally. So here's the software used on the caching servers. It's roughly equivalent evolution on this side. So taking a look at the web server software to start with, right at the beginning, everything was done in Varnish. I've got a soft spot for Varnish, but using it in this configuration with a huge memory mapped file was, again, just shocking for performance. So what helped us get up from the 4 gig to the 20 gig was replacing Varnish with Nginx. Unfortunately, at the time, we thought it was a good idea to sandwich it between 2 Apache daemons. So that one was an obvious one to remove. And to get from the 20 gig to the 70 gig, we're now doing everything inside Nginx. And we chose OpenResty to do that because we can write all the business logic in Lua and still get the fantastic performance. On the BGP side, we started off with ExaBGP, but we have moved to Bird, partly because it allows us to use BFD and reduce the failure detection time inside the battery, but it also allows us to do administration a bit easier. We've also got control tools around the side. They manage things like cache drives, DNS, real-time stats, central communication. And as you can see, we are going for the hat trick of let's rewrite this in a different language. So that's where BIDI is at now. Here are some of the plans for the future. Our first plan is for something that we call Smart Shard. At the moment, BIDI's content sharding is fairly dumb. All the batteries pretty much serve the entire working set. But as you saw with that offload graph, the size of the working set's ever increasing, and we can't just keep buying more disks. So we're completely designing a new traffic steering algorithm that sits in the matchmaker. And this algorithm has 2 modes of operation. Depends on whether a program is popular or if it's unpopular. So for the popular content, this will be served by all batteries, but the edge capacity is going to be prioritized unless they're reaching their limits. Then for unpopular content, it's going to restrict these to a smaller set of the core batteries, and it will use weighted rendezvous hashing so that we can give a higher capacity battery a slightly bigger slice of the pie. The aim for this is that it should overall improve offload to allow us to cope with those future demands in working set growth, and it should allow traffic to be offloaded nearer to the edge as well. Ooh, IPv6. Like many other organizations, I'm sure, all software that we've built has been v6 capable from the start. But Susan from Hurricane Electric is not going to be impressed with this. We haven't actually got round to joining everything together yet. There's still some work for us to do here, particularly around the root ingest processing in the cloud parts of our algorithms, but it's certainly on our radar. Also in the future, we're aiming to build a web portal, and that's for ISPs that have embedded BIDI caches in them, and that allowed them to do things such as view the monitoring stats for the servers, schedule traffic drains, and just inspect the routes that are received over BGP back at them. I mentioned this right at the start. BIDI does currently only serve video on demand, and we kind of want that to change. We want BIDI to serve the live linear streams too, all these ones that you see here. We've still got some feature development to do to make that one possible, but we are aiming quite soon. So hopefully within mid-2021, BIDI should also be serving those. A fairly exciting one for us, we're prototyping a new unit of deployment, and have you seen the current minimum deployment requires a switch and at least 2 caching cells. So that's just no good for deploying deeper into the network, as that amount of hardware is wasteful. It's too expensive to deploy at that scale. So this new server will be able to be deployed standalone. It won't require a switch. And at the same time, we're just completely changing all the hardware inside too. So they're being shrunk from 2U to 1U, partially to allow a higher rack density. The NIC will provide dual 200 gig ports, but we're only actually targeting these in environments that have 100 gig capability to start with. We're going down from a dual socket to a single socket CPU. And in these things, the CPU's main job is to just marshal traffic from the disks to the NIC. And that's all it really needs to do. And nowadays, we're able to get enough PCIe lanes in a single socket to make this one possible. And there'll also be PCIe Gen 4 lanes as well, so you get double the bandwidth for that. On paper, this drop to single socket possibly could give us energy savings of about 33% as well. So we're hopeful for that. Finally, as I mentioned before, we're provisioning a new POP in Slough, and that's at Equinix LD7. All the network infrastructure is in there, it's ready to go, it's operational. The BIDI caches themselves are expected to be operational in about March 2021, so hopefully not too far away. That's about as much of BIDI as I can go through in 25 minutes, so are there any questions?
Alistair, that was a gorgeous presentation. Thank you so much for that. Slightly short than one episode of EastEnders, I've learned as well.
Oh, well, they're cutting down for the moment.
But timing, perfect BBC timing there. You've not let the side down one iota. Before I hand over to Tom to do the questions, just a quick advert that if you want to reply back on how gorgeous that presentation was, don't forget the UKNOF surveys. You can click on the survey link there and add your feedback. Tom, I see 3 questions. No, 6 questions in the queue now, coming thick and fast.
There are many questions. We're going to have to rattle through these, yeah. The first question is from Andre Kaletka. Apologise if I have butchered your name there, Andre. Is there support for IPv6 in BIDI? I think there is.
Yeah, well, yeah, it's very mixed. So we've built everything to be v6 capable. The caching servers themselves are perfectly fine if they're given a dual stack address. The bits that we're mainly struggling with are getting the routing through the cloud. So the ingest of the routes over BGP forwarded into we call it the central BIDI brain. But yes, it's one of those annoying ones where 90% of the way there, but we haven't got the final bit in there. So after we've managed to get the 4 big things that I've mentioned here out of the way, that'll be our next bit to attack.
It is a 2-part question as well. Oh. Do you somehow protect HTTPS private keys in hosted BIDI batteries?
Yeah, so we do. Yes, so we've got physical protection and not the cache drives, but a lot of the system drives are encrypted as well, so they are kept private in that terms of that. We only use elliptic curve as well, so you get perfect forward secrecy with that. So slightly less chance should you be intercepted.
Okay. Second question was from Andy Davidson. This was an excellent presentation. Thank you, Alistair. How do you decide which of the 24 data center locations is a customer request that a customer request will be served from? Is it, for example, DNS or BGP/Anycast or something else?
Yeah, so if you remember right at the start, we don't try and guess it. We get all of the ISPs that we have embedded caches in to actually advertise which customer route should be served by that specific battery. So that's advertised to the battery over BGP. We then aggregate it in our central BIDI brain. And the matchmaker, the thing that actually dishes out, okay, you've come in on this IP address, you need to be served by this battery. That's what just uses those ranges. It does a longest prefix match, has some tiebreakers in there. So AS path, community strings, if we're doing that with the ISP. And that's how it decides, okay, you're getting that. For now, that is anyway. With Smart Shard, it'll then have a bit more additional logic. So it'll also look at how loaded that battery is. Is it overutilized in terms of throughput, or perhaps it's not offloading as much as we should? And it could start shedding that back to perhaps the least preferable choice if it needs to. But at the moment, it's fairly dumb.
Awesome. Third question from Dave Wilson. Do you have read versus write data for the SSDs?
Read versus write. I'm not quite sure what the...
I'm wondering whether or not this is related to the amount of wear and whether or not it is a...
I see.
The fact that when they fail, then perhaps... Not sure if
yeah, so we are very read heavy, but SSDs really don't mind reads at all. That doesn't tend to shorten their life one bit. Yes, we've had In recent times now, we're seeing SSDs that actually do perform as they are on paper. So you get a certain amount of drive writes that a drive is rated for, and we're actually achieving that now. Right at the start, so I don't know, 2 years ago, we weren't getting anything like that we'd see on paper. They'd burn out much more frequent than that. But now, yeah, the drive write performance you get on paper is roughly matching what we're getting out of them.
Okay, I'm actually a little bit curious as to which SSDs you're finding are the most reliable.
Yeah, it's one of those things. I can't give the exact names, but it's a cross section of vendors that we've used now, and there really hasn't been any bad outliers in the last 2 years. They're all pretty much as good as each other.
Well, that's good to know. Fourth question, Peter Hicks. Are you looking at, or do you currently use multicast for delivery of live streams on providers that can support it, e.g. Virgin Media?
Yeah, so I mentioned at the start that this came from R&D, the idea for BIDI at the start. Now that it's put into our camp and we built it into a production system, R&D are now looking at that exact thing. So they're looking at how they can use multicast to distribute the live streams, the big ones, the Boris Johnson type cast on Saturday. At the moment, we don't do it in BIDI. It's no multicast there at all, but it's something that R&D are looking at, the same team that built up BIDI to begin with.
Okay. There was a clarification submitted by Dave Wilson for the previous question there. I ask if the hot data set, this is related to the read versus write SSD information. I ask because if the hot data set is constantly changing, that churn would explain why you burn through them so fast.
Yeah, it's another reason for Smart Shard as well, because at the moment we all batteries pretty much serve the entire working set. We have actually split that in half, but it's as good as serving the entire working set. So what we're trying to do now is, in the first place, don't send every request to every battery, so the long tail doesn't all get sent to it. So that's the main thing. Well, it's another thing with Smart Shard is that it should improve the lifetime of these caches as well, because we're just not writing as much to disk. Something we did earlier on that someone in our analytics team spotted actually is that we get quite a lot of requests that are only ever for one piece of content. So that there's at the very end of the long tail, you'll get someone that just requests that once over a month period. And actually that's quite a large part of the large tail. So what we ended up finding is that we'd get the writes to drive to do the initial cache, but it'd never be requested again. So it's a completely wasted write. So what we do now is actually have a threshold. We say we must have had at least 2 requests for a content item before we even save it to disk. Actually, that saved quite a lot of lifetime for us.
Awesome. Next question from Adil Sadiq. I am a student from Nottingham University, and all questions are good questions, Adil. When you prioritize popular programs, does that mean it will no longer follow net neutrality?
Oh, sorry, can you repeat that one again? I broke up just the last minute.
When you prioritize popular programs, does that mean that it will no longer follow the net neutrality rules?
Oh, yeah, sorry. Yeah, as a fellow Nottingham student, hello. So when I say in terms of prioritize, it's not in terms of quality of service, it's just in terms of what capacity do we have. So we've got loads of capacity in lots of networks all around the UK. We don't need to stick, bargain hunt on all of them all the time. We can just have that, just a small number of perhaps BBC hosted batteries. It won't reduce the quality of service as much because it's not got huge throughputs anyway. In fact, it shouldn't reduce it at all. So there shouldn't be, in my mind, any neutrality problems with that one, because you can always get access to the content no matter what service provider you're on. And it should be the same quality of service as well. If there isn't, then we'll stop it. We'll find out what's causing that. But yep, sure. Shouldn't be any problems with that. We're just prioritizing capacity.
Marvelous. And the final question. You've done extremely well answering all of these. I think this is wonderful stuff. From Richard Savage, are you looking to put more cache nodes out in ISP networks? I think there was a slide on this, like other CDNs, or to keep it all in BBC DC deployments?
Nope, so we are in 3 of the ISPs at the moment, and we've still got some deployments inside those to complete. But once that is finished, then yep, we're more than happy to start embedding in other large ones. As long as we're meeting the thresholds of if it can actually have enough traffic to meet the minimum deployment unit, so the 100 gig MBIDI, for an example, then yep, we're looking to embed. But at the moment, we do have to complete the major providers that we're currently in.
Fantastic. I think that's everything then. Thank you so much for answering all of those questions. It was a beautiful presentation.
Great. Thanks, Tom.
Simon.